Hi. Okay, let us continue with the example 21 until 24 from the lecture notes all about implicit differentiation. From the example 21, there are two questions involve trigonometry and also together with the x and y. So normally we will write it as a differentiate implicitly with respect to x. So there are four terms here and you double check how many terms with y. 1, 2. So it means later we will appear 2 dy dx. So differentiate y, we get dy dx. Okay, plus differentiate cos, we get negative sine y. And do not forget, you must have the dy dx. And equals to differentiate x is a 1. And differentiate cos x, you get the negative sine x. So we try to simplify it. Okay, so that since there is a dy dx, there are two terms here. So you just simplify, you get a 1 minus sine y. And the right side is a 1 minus sine x. So lastly, the dy dx as a subject. So normally we will get the first derivative in the rational form. Okay, where our answer is in terms of x and y. Okay, that's a question A. Okay, for the question B. Okay, so you are given sine x minus y. So there is only one terms, but the function under the sine is involved subtraction between the x and y. And by the right hand side is also one grouping with the relation product. So obviously the right hand side we need to do the product rule. Okay, so you take note, this one will be product rule. Okay, so as usual we write it as differentiate implicitly with respect to x. Okay, so the left hand side you will obtain cos x minus y. And we have to differentiate x minus y. So this is the left hand side. Okay, so the right hand side we have to using the product rule. So it will become keep the y, differentiate the cos. So you get a negative sine x. You may using the bracket to represent that is a process of differentiation, u prime and v prime. Okay, and then plus keep the cos. And we are differentiate the y. So when you differentiate the y, we obtain dy dx. Okay, so before going to simplify it, you double check first. Okay, so we found that we still have a notation d dx. It means the left hand side, the process of differentiation is not complete yet. Okay, so we need to continue to copy down the related terms. And this one, we put it in bracket. Differentiate x minus y is 1 minus dy dx. And the right side simplified it, you get negative y sine x plus cos x dy dx. Okay, so for me, I would like to using simplification. So you double check, this one you have to multiply in. So it means the left hand side you have two terms, the right hand side you also have two terms. Okay, so we can observe and only moving the terms to the left side. Okay, so obviously we let the dy dx as a subject. Okay, so you look at it. The dy dx will multiply with the negative cos. So negative cos x minus y. And this one is a plus. When you move to the left hand side, become minus cos x. Okay, you get a point here. And the right hand side, it will become negative y sine x. Okay, the exiting terms at the right hand side. And this one, do not forget, cos x minus y is multiplied with 1, but in front is a positive. So when you move it to the right side, it will become minus cos x minus y. So obviously you found that the four terms all together with negative. So before moving it to the right side, I prefer to simplify it. So I make it as a dy dx positive cos x minus y plus cos x equals to positive y sine x plus cos x minus y. Not every time we have to do so, because in this situation we found that the four terms with coefficient negative. Okay, to make the workings that much more easier, then we multiply negative 1 to both sides. And lastly, let the dy dx as a subject, and the right hand side for sure it will be in terms of fraction form lah. Okay, and for sure you found that they are unable to simplify again because there is involved the compound angle cos. Okay, and also the cos x, there is nothing that can be applied anymore. So we just leave it. So this as a final answer for the example 2021. For the example 22, it will be, other than finding the dy dx, we also have to evaluate the values when you are given the x and y values. So in this case, you will find that you are given the x and y in a coordinate form, which is x equals to 2, y equals to 1. So we just do differentiate implicitly. Okay, differentiate implicitly with respect to x. With respect to x, to remind you that you are doing the implicit differentiation. So identify first how many y you have here, 1 and 2. So it means later you will have 2 dy dx, and double check this is basic, and this one is a product. Okay, so I hope that you understand what I'm doing. Okay, in this case, normally you can make it as negative 2 x to the power of negative 2, ready with this form, okay, by using the basic rules. So you can do the question directly. So 3, so differentiate y cubed will be 3y squared dy dx. Okay, and then minus 2, that is coefficient. So x power negative 2, so it becomes negative 2 x to the power of negative 3. Remember, reduce by 1. Okay, so the left hand side settle, and the right hand side it will be keep the u, differentiate the y squared. So differentiate y squared we have practiced before, so you get the 2y dy dx plus y squared differentiate the x, which is equals to 1. So this is why I say that you are having 2 dy dx appear, right? Okay, so let us simplify it. 9y squared dy dx minus 2xy dy dx, grouping the like terms, and the right hand side will become y squared. So this one, do not forget, negative 2 is a positive 4. After you shift to the right side, it becomes minus 4 over x cubed. Okay, so you found that the right hand side there are 2 different terms. So it means in order to get the dy dx in a final form, the right hand side we need to equalize the denominator, and the left hand side we just need to do the factorization. Okay, so this is 9y squared minus 2xy, and the right hand side will become x cubed y squared minus 4 over x cubed. Okay, so make sure the right hand side is a single fraction form. So actually just now we found that actually there is a y as a common factor. So when we're moving to the right side, okay, so let us write dy dx equals to x cubed y squared minus 4 over x cubed multiply with 1 over, so we can factorize out the y, so which is 9y minus 2x. Okay, so lastly, you simplified it, you get the x cubed y squared minus 4 over x cubed y 9y minus 2x. So you get the expression for the first derivative dy dx. So because the question asks us to evaluate, right? Evaluate. Okay, so we need to evaluate the dy dx when x equals 2. So looking back again, the coordinate, x is equals to 2, y is equals to 1. Okay, so it means you get the dy dx equals to 2 to the power 3 times 1 to the power 2 minus 4 all over 2 to the power 3, and then this is 9 times 1 minus 2 times 2. Okay, so the numerator you get that is a negative 2, and no, it's a 8 minus 4 is a positive 4. Okay, because 2 to the power 3 is a 8. Okay, and the denominator you will get that is a 8 times with 9 minus 4, which is 5. So obviously it can be simplified and it will become a 1 over 10. Okay, so this is example 22. Okay, so let us move to next example 23. So start from example 23 and 24, they are the different kind of question. 23 is about finding until second order derivative, and the example 24 it will involve the proving. Okay, so I'm show you one example. Okay, so for the part A, in order to find the second order derivative, so both using in terms of x and y. Okay, so we differentiate implicitly from the question. Xy plus y squared equals to 3. So product rule, basic. Product rule, basic. Okay, so we differentiate implicitly with respect to x. differentiate implicitly with respect to x. Because of with respect to x, the derivative that we produce is over dx. Okay, so from here it will be x dy dx plus y times 1 plus, so this one settle the first pair, product rule, and then plus 2y dy dx, which is equals to 0. Okay, so after that you can try to simplify the dy dx. Is a x plus 2y, okay, and plus y equals to 0. Okay, why this time I'm not express the dy dx as a subject? Because the question didn't asking for first derivative, it's asking directly for the second order derivative. So you just need to factorize out the dy dx. So later you don't need to do the product rule twice. Okay, you factorize it, then you do it one more time, differentiate implicitly with respect to x. Okay, for the second time, because you would like to obtain the second order derivative. Okay, as usual, the product rule. So keep the dy dx. Differentiate x plus 2y. Remember, x plus 2y is just a summation. So it just differentiate x is 1. Differentiate 2y, you get 2 dy dx. Okay, and then plus x plus 2y. And you have to differentiate the dy dx. So from here you obtain the second order derivative. Okay, so the first product rule settle, and then do not forget about this. Differentiate the y, you get the dy dx again. Okay, and differentiate the 0 for sure is equals to 0. Okay, so now we need to finding, expand and everything. So you have to be careful with it. This one you will obtain d squared y dx squared. And these two you will obtain dy dx with the power of 2. So don't get confused with these two expressions. Okay, so let us simplify it. So from here you will obtain dy dx plus 2 dy dx squared. Okay, expand it, and then plus x plus 2y d squared y dx squared plus dy dx equals to 0. Okay, so because lastly we are required the d squared y dx squared as a subject, right? So d squared y dx squared with the coefficient x plus 2y, and the right hand side you found that these two actually is just equivalence, right? So that is a 2 dy dx. So when you shift it to the right side, it will become negative 2 dy dx minus 2 dy dx squared. Okay, because the question is just asking you to find it in terms of x and y. So it means that we have to look back again just now the dy dx that we obtained. Okay, so it means from here. Right, from here you will get that dy dx is equivalent to, so the positive y, it will become negative y over x plus 2y. So we have to substitute the dy dx in terms of x and y as well in order to finding the second order derivative. Okay, so let us substitute here, negative y over x plus 2y. Okay, so the right hand side it will become negative 2. Okay, so what you will obtain just now, negative y over x plus 2y. Negative y over x plus 2y. And minus 2 negative y over x plus 2y in terms of square. Okay, so lastly we need to simplify it. So this one you get the positive 2y over x plus 2y. And the right hand side you will get that is a minus 2y squared over x plus 2y squared. So in order to simplify it, we need to equalize the denominator. So it will become x plus 2y squared. So this is 2y times with x plus 2y minus 2y squared. So lastly, you will obtain the second order derivative where you shift the x plus 2y. Okay, this one you move it to the right side. So it means you will get d squared y dx squared equals to, the denominator will become the power 3. And the numerator we can expand it, or you can just factorize it as the 2y outside. Right, you found that this is a common factor, right? 2y. So inside you left x plus 2y minus y. Okay, so lastly is equivalent to 2y x plus y over x plus 2y to the power of 3. So lastly, we obtain the second order derivative in terms of x and y. Okay, so this is example 23a. Okay, so example 23b is much more easier. You can give it a try. Okay, then I will move to the example 24. It will be the last example for the differentiation implicitly. Okay, so my dear, when you're looking at this, okay, when a question given you exponential with a negative, normally I will start to simplify it. Okay, because simplify will make the procedure is much more easier. I don't like the exponent with the negative coefficient, so I will multiply ex to both sides. Right, so when you multiply ex to both sides, okay, ex to both sides, okay, because we want to simplify. Not every time, just this is a special case, So I will get ex equals to e negative x multiply with ex cos x. So this one, as we know that they're having the same base, so when they have the same base and with the product, so their power will be summation. So e negative x plus x, you get e to the power of 0, which is equivalent to 1. Right? So it means lastly, you will find that we may start the example 24 with ex equals to cos x. So we are differentiate implicitly to show the second order derivative. Okay, we have to show it until this form, So let us take a look how we do it. So the left hand side is a product rule. So differentiate implicitly with respect to x. So the left hand side, keep the u, differentiate ex, you still get back ex. Plus, keep the ex, differentiate the y, you get dy dx. And differentiate the cos, you get the negative sign x. Okay, so because the question asks you to do the second order derivative, so from here actually we can do the simplification where ex is a subject, so which is y plus dy dx equals to negative sine x. You get a point here? Okay, then from here we can differentiate implicitly one more time. Okay, differentiate again. And you have to write down is differentiate with respect to x again, because to achieve the second order derivative. Okay, so from here you will obtain the first one ex. So differentiate the y, you get dy dx. Differentiate dy dx, you get second order derivative. Plus y plus dy dx. And this one is a ex. Okay, because the differentiate ex is to get back itself, but the right side now is differentiate sine, you get positive cos. So the negative you memang sedia ada, so differentiate sine, you get a positive cos x. Okay, so when it comes to here, actually we should look back again the question. The question asks us to prove. Okay, did you notice that the proving part, there is no exponent? Okay, it's a second order derivative, dy dx and y only. So we must try to make the exponent disappear. So just now I multiply the ex, so now I will divide the ex to both sides. So it means you will obtain dy dx plus d squared y dx squared plus y plus dy dx. And the right hand side will become negative e negative x cos x. So you look back again the question, is it this one? The terms that I'm highlighted, e negative x cos x, is equivalent to the y, isn't it? Right, e negative x cos x actually is equivalent to the y. Okay, this is equivalent to the y, so you are going to substitute it as a y. So you will find the exponent form will disappear. So let us simplify it. You will get that d squared y dx squared plus 2 dy dx, okay, due to these two, plus y equals to negative y. The negative is still there. We only substitute e negative x cos x as a y. So lastly, you grouping the negative y to the left side, you will get exactly the same like the question. Okay, so it's exactly the same, then you get it short. Okay, so All this example 19 to the example 24 is all kind of implicit differentiation that require the basic skill. So please do more exercise from your tutorial, then you will more understand about it. That's all for today. See you. Bye.